Alright, this is 10.5 in advanced geometry, and we need to do a little practice problems before we do our practice worksheet of stuff that you learned in Algebra 1, or at least you should have learned in Algebra 1. First is how to square a binomial. Like a binomial is two terms, right? And as a quantity, they want to square it. Well, probably your teacher showed you in algebra to just kind of say, well, squared means take it times itself, so we want to take x plus 2 times x plus 2, and now we can FOIL this out by taking the binomial times the binomial. So the first terms times each other is x squared, the outside terms is 2x, the inside terms times each other is 2x, and the last terms times each other is 4, and then we can combine like terms right here and get 4x plus 4. But if we was to do a ton of these in a row, when you square a binomial, you'll notice that your outside terms and your inside terms are always the same. So there's like a shortcut to it. What you do is here's the shortcut. You first square the first guy, right? So 3x squared, the 3's got to get squared and become a 9, and the x has got to get squared. Let me go down a line just to show you. And the x has got to get squared and become x squared. So you square the first guy. Then, since when you take your outside terms times each other and your inside terms times each other, it's really you're just multiplying these two guys together, and you'll have two of them. First, you take 3x times 5 and get 15x, and you double that, and you get 30x. So we call that twice the product, right? We square the first guy, we take twice the product, and then finally you square the last guy. And 5 squared is 25. So you can get a binomial squared done in one step by using the shortcut. I just want to show you that if you was to write that out, 3x plus 5 times 3x plus 5, that's what you would have got. You would have got 3x times 3x is 9x squared. Outside terms times each other is 15x, right? Didn't you get the product of those? Inside terms is 15x. There's why there's two of them. And last terms times each other is 25. So this is for a binomial squared only is the shortcut. So here's 4 examples. Here's how it works. You square the first guy, 25x squared. Then you take twice the product of these. Well, what is the product of these? It's 10x. And then you take that times 2 and you get 20x. And then you square the last guy and get a 4. So we'll do that again. You square the first guy, 36x squared. You take twice the product, so the product of these is a negative 24x, and we need to take that times 2 and get a negative 48x. And then you square the last guy and be very careful. Negative 4 times negative 4 is a positive 16. This dude should always turn out positive, and this dude should always turn out positive because they had been squared. And a negative times a negative is a positive. But the middle guy will always have the same sign of whatever this is in your parentheses right here. So again, just another practice. We square the first guy. The product of these is 3x, but we need twice that, so you get 6x. And then we square the last guy and get a 9. Square the first guy, 16x squared. The product of these is negative 28x. We need 2 of those, so that'd be negative 56. Negative 28 times 2, negative 56x. You can always use a calculator to take stuff times 2. And then square the last guy and get a 49. So this is what I really recommend you try to do. If you forget that shortcut, you can always bail yourself out by writing them times each other. It's a binomial times a binomial. You'll FOIL it. But if we can learn that shortcut, life will be a lot faster for us. The other thing we need to practice is solving an unfactorable quadratic by using the quadratic formula. So this is the quadratic formula right here. This will tell you what x equals. Like if you want to solve for x, I guess I should say that x equals all of this stuff right here. And remember, the standard form for a quadratic equation is it's got to be equal to 0. A, B, and C are the 3 variables involved in this equation. A is in front of x squared, B is in front of x, and C is the constant term. And you can see right here that this guy is unfactorable, because I cannot find 2 numbers that multiply together to be 5 and add together to be 8. 2 integer numbers, that is. So what I'll do is, I personally think that this is the greatest idea in the world right here to save your life, is do A equals B equals C equals. A is right here, it's 1, B is 8, and C is 5. So I asked on your practice worksheet that you write the quadratic formula down so that way you have it, because you're going to need it for your homework today. So let's substitute these numbers into the quadratic formula. It says x will equal the opposite of b, so that would be -8, plus or minus the square root of, so put this big old honker radical, b squared, so I can do that part in my head, minus 4 times a times c. All of that is over 2 times a, which will be 2. And then what we need to do is clean up what's in here. Right? So 64 minus 4 times 1 times 5. Well, this part right here turns out to be a -20. Right? So you have this. You have -8 plus or minus 64 minus 20 over 2 times a is just 2. Right? Over 2. And that's really -8 plus or minus the square root of 44 over 2. And here's kind of a little secret. When you're doing the quadratic formula, if this number is not a perfect square, then this equation was not factorable. Right? I mean, that's just what it's all about right here. So whenever this discriminant, that's what this is called, the number underneath the radical, is not a perfect square, that means you couldn't factor this guy in the first place. So here's what we do. We got to punch that in our calculator. And we have to do what's in the numerator first. This is really -8 plus the square root of 44 over 2, or -8 minus the square root of 44 all over 2. So that's a plus or minus situation. So let me do the first guy. It's -8 plus the square root of 44. And see, that fraction bar is a grouping symbol, so you want to hit equals after you do that. Right there. That's what the entire numerator is. Then we need to divide that by 2, and that's approximately -6.8. 0.68, I should say. Or the other guy was -8 minus the square root of 44, and you hit equals, and then you divide that by 2, and you get a -7 point something. I lost it. 7.32. So there's the two solutions to this situation right here, just by solving the quadratic formula. These are the x-intercepts, where that parabola crosses the x-axis. Let's do one more of these bad boys right here. This is not factorable because I can't find two numbers that multiply together to be -8 and add together to be -5 right here. So what I would end up doing is a equals, b equals, c equals. A is -2, b is -5, and c is 4. So I will substitute those into my quadratic formula. The opposite of b, which would be a +5, plus or minus the square root of b squared. Remember, when you square a number, it will turn out positive every single time. So be careful. Use your brain, not your calculator. -5 squared is +25, minus 4 times a times c. All of that over 2 times a, which is -4. And then I'll clean up my discriminant. That number underneath the radical is called the discriminant. So you'll have 25, and then this turns out to be a +32. So you have 25 plus 32 underneath there. And then that equals 5 plus or minus the square root of, that would be 57. And you could tell that that was not factorable because that discriminant is not a perfect square. So you just punch those two guys in. You'll get 5 plus the square root of 57. Hit equals after that and divide it by -4 and get -3.14, or 5 minus the square root of 57, hit equals, and then divide it by -4, and you get +0.64. And those are approximate answers. So people ask, why would you even want to factor an equation if this quadratic formula works every time? Well, one, the quadratic formula gets a little old of trying to do. And two, you'll learn later in algebra courses of why factoring is a good thing compared to the quadratic formula. But it's one of those things you got to experience before you can get there. So finally, to the practice worksheet. It's very simple. We're only going to do the front side of this because the back side is less than 10.7. It says a tangent line. A tangent line is any line or segment or ray that touches the circle in exactly one place right here. Like see this segment SR right here, it only touches the circle in one place. So this point R is called the point of tangency, and this segment ST is a tangent segment because it only touches the circle in one place. See, that guy right there is not a tangent segment because it touches the circle in more than one place. So if it touches in more than one place, that's called a tangent. It's not the same thing as like our sine, cosine, and tangent kind of thing, but it's the same word. And here's the basic rule. If a radius, which that is a radius, touches a point of tangency, where point R was the point of tangency, the angle formed between that tangent segment right here and the radius is always 90 degrees. And here's a simple proof of that, is if this thing continued out, that radius continued out to a diameter, isn't this right here a semicircle, which measures 180 degrees, and this point is on the circle, so it's like an inscribed angle in that, so that's got to be half as much, which is 90 degrees. So basic rule of thumb, if a radius or a diameter touches a point of tangency, there's a 90-degree angle right there. And then the other thing that they're saying right here is if you have two segments from the same exterior point, notice C is an exterior point, are tangent to a circle, then these guys are congruent to each other. So it's real simple. These guys are both tangent. They're to the same exterior point. That means that they're congruent. So x plus 3 should equal 7. And x equals 4. Please show this work right here. It's a real simple thing. I know you can do that mentally, but just want to see what's going on right here. In number 2, you've got a radius touching a point of tangency. So this is a right angle right here, and this shape is a right triangle. They ask us to solve for x, so we can use the Pythagorean theorem to do that. I need you to put that right angle box in your picture, and x is the hypotenuse, so 15 squared plus 20 squared should equal the hypotenuse squared. 15 squared is 225. 20 squared is 400. And that'll equal x squared. And 625 equals x squared. And now we square root that, and you can do that in your calculator. The square root of 625 comes out real nice to be 25, meaning it was a perfect square. And we don't use the negative value because really x is plus or minus 25. We don't use the negative because this is a side length which has to be positive. Cool. This guy right here, this is an exterior point, and these are both tangent segments, so these guys have to be the same. And then we'll solve for x, so I'll subtract x from both sides. And add 5 to both sides. And x equals 20. This guy right here, got to be 90, because that's a radius touching a point of tangency. And here's where we get a little tricky, because this distance right here is x. I need to know this entire distance right here. This entire distance is the hypotenuse of our right triangle. Well, we do know that this right here has to be 15 because it's a radius of this circle, and if that radius is 15, this has got to be 15. So this entire distance is x plus 15. So to do the Pythagorean theorem, we'd say this leg right here, 15, needs to get squared. Add it with this leg right here of 36. It needs to get squared. And that should equal this entire hypotenuse, which is x plus 15, and that needed to get squared. So we can clean this up real easy. 15 squared is 225. 36 squared, I do not know that off the top of my head, so I will punch that in my calculator. I actually do know what 36 squared is. My bad. It's 1296. And then this is a binomial squared, so that's where we can use this cool little shortcut. We square the first guy. We take twice the product of these. The product of it is 15x. We need twice the product, which is 30x. And then we square the last guy. And 15 squared is 225. So here we have a quadratic equation. We need to get it equal to 0 before we can solve it. So I'll subtract all this stuff over and watch this. The 225 when you subtract it away from 225 is 0. And you still got to subtract the 1296 over, so 0 will equal x squared plus 30x minus 1296. Notice the 225s, they subtracted out to be 0. So, if you would like to try to factor this, you are welcome to. Try to find two numbers that multiply together to be a negative 1296 and add together to be a positive 30. And you know, factoring is pretty simple when the numbers are small, but negative 1296 is a mega number. I'm just going to go straight to the quadratic formula, to where a equals 1, b equals 30, and c equals negative 1296. Like, I love factoring just as much as the next guy, but I'm not going to spend 15 minutes trying to find two numbers, because maybe it might not even happen. It's like, oh my goodness, this is a large number. So that quadratic formula, again, is the opposite of b plus or minus the square root of b squared, so you got to take 30 and square it, you get 900, minus 4 times a, which is 1, times c, which is negative 1296. All of that needs to be over 2 times a. So a big pet peeve that I have is you don't make this radical symbol large enough to fit everything underneath there, and you don't make this fraction bar long enough to fit everything on top of there. Please make sure you're making it look right. Now what I notice is I've got three numbers here times each other. It's a negative 4 times 1 times a negative 1296. I got an even amount of negatives. That's great, because that's going to come out to be a positive right there. So you'll have negative 30 plus or minus the square root of 900 plus 1296 times 4 is 5,184. Let me double check that. I'm going to add that to 900 right away while I got my calculator open and get 6,084. So that was really over 2. And this equals negative 30 plus or minus the square root of 6,084. If I could write it correctly. Over 2. And now I'll punch that in. First, let me show you something. I want to check to see if 6,084 is a perfect square. And haha, it is. What that means is that equation was factorable, since that was a perfect square. But you know what? Like I told you, I don't want to spend the time to find two numbers that multiply together to be 1296. That's such a large dude. So now I'll go to my calculator and I'll get negative 30 plus 78. Hit equals when you do that and divide it by 2. And you get 24. Or we got to figure out the other answer. Negative 30 minus 78 and divide it by 2 and get a negative 54. That's what x could equal algebraically. But realistically, x can't be this negative 54 because we're talking about a side length. Now, x could possibly be a negative number, right? Because they're adding 15 to it, you know. But you got to make sure that the result, when you add 15 to it, comes out positive, and it won't when x is negative. So this is the answer to the question, x equals 24. What does that mean? The two numbers that multiplied together to be negative 1296 and add together to be 30 was a negative 24 and a positive 54. Right? Those will multiply together to be negative 1296 and add together to be positive 30. But that would have taken us a long time to find those two numbers. So I recommend when you get large and in-charge numbers, if you don't have to factor, because the instructions don't tell you to, use the quadratic formula. And it looks complicated. The more you use it, the easier it gets. So let's do one more of those problems. Let me get rid of all this work right here. And we have, again, a radius touching a point of tangency. So we have a right angle right here. And we can set up our Pythagorean theorem. I'm a fan of you putting this total distance in there of x plus 8. And that means that x squared, hey buddy, plus 12 squared should equal x plus 8. As a quantity, it's got to be in parentheses squared. So x squared is x squared. 12 squared is 144. And this binomial squared, we used a shortcut. You square the first guy. you take twice the product. So the product of these is 8x. I need twice that, so that's 16x. And then you square the last guy and get a 64. Then a real good thing happened. This is a quadratic the way it looks, but don't we have an x squared, the same amount of x squareds on both sides of the equal sign right here? So a natural move is to say I'm going to subtract x squared from both sides, and when you do that, those will go away, and these will go away. So you're left with 144 equals 16x plus 64. This is beautiful, because now you only got an x to the first power. We can solve this with old school algebra. Subtract 64 from both sides, and you get 144 minus 64 is 80. That equals 16x. And divide both sides by 16, and x equals 5. Bingo! I like it right here. And that turned into a 5, 12, 13 right triangle, one of those that I asked you to memorize. But because the x squares canceled each other out, we didn't have to factor, we didn't have to do quadratic formula or any of that jazz right there. And then circumscribed polygons is when a polygon is circumscribed about a circle, all of the sides are tangent to the circle. Circumscribed mean that the circle fits inside of there, and it doesn't, like, it only overlaps a segment in one spot basically. So those 3 points are points of tangency. Well, we can use what we learned from above. It says for each figure find x and then find the perimeter. We can use what we learned above, that if a segment, a tangent segment, and another tangent segment intersect at a point outside the circle, that those guys have to be congruent. So if this dude's 13, this dude's got to be 13. If this dude's 10, this dude's got to be 10. And if this dude's 17, that's got to be 17. Put it in the picture. So they say find x. X is this whole length. X is 23. And then find the perimeter. We'll use a capital P for the perimeter. And I think that this is much an easier process to do this. Figure out these entire lengths right here. We just figured out that that was 23. This is 27, and that is 30. And add those three numbers together in your calculator, and get the perimeter to be 67 units. We always put a label on perimeter, and it's to the first power. Since they don't give me a label like inches or feet or whatever, we will put units. So let's find x right here. This x has got to be the same as that. They tell us this whole thing is 26. Okay. This little dude's 18, so that means that this little dude right here has got to be 18. And now since this is 26 and that's 18, this is going to be the difference of those, which is going to be an 8, meaning that that's an 8. And if this is 14, that's got to be 14. So we just figured out that x equals 8. And now all of these entire side lengths, 18 plus 14 is 32. And 8 plus 14 is a 22. So we'll add 26 and 22 and 32 together to find the perimeter, equaling 80 units. Last one of these bad boys. This little guy is 2, that little guy is 2. That's 6, this has got to be 6. This is 4, that's got to be 4. And that means that this whole length right here is 10, aka x is 10. This is 6, and this is 8. And the perimeter would be 24 when you add all those together. You can see it was a right triangle, 6, 8, 10, very popular right triangle. So that's section 10.5. Your homework is from the book. Do problems 17 through 27, and then 44 through 52. Let me know if you have any questions, and have a good one. Alright, this 10.7 is advanced geometry. More circle stuff today. Today, this first thing says if you have two chords inside intersecting in a circle, then the products of the lengths of the chord segments are equal. So basically, this little red guy and this little green guy are like chord segments, right? They make up the parts of the chord. If we multiply those two dudes together and set that equal to the other two dudes times each other, 3 times 6, which is 18, and that's so simple that you can just multiply them together right away, then we could solve for x, and x would equal 9 right there. So the product of the chord's parts are equal to each other. So here, 3x times 2x is 6x squared, and that will equal 5 times 6, which is 30. We want to get x squared all by itself, so x squared will equal 5. And since there's no x to the first and x to the second, we can square root both sides, and x will equal the square root of 5, which is about 2.2. Notice we put both the exact and the approximate answer on that. And let's do that again here. 3x times x is 3x squared, and that will equal 8 times 6, which is 48. Get x squared by itself before we square root, and x squared equals 16. So x will equal 4. We don't have the negative 4 because it's a side length, so there's no plus or minus on this. 16 was a perfect square. And then number 12, it's like so obvious. It's like, don't try to set it up the hard way and say, oh, this is a radius, so this has got to be x plus 2. And then don't try to take this times this and set it equal to that times that. It's like, don't all these things have to be 5, right? So basically you're saying that x plus 2 has to equal 5, right? Because they're all radiuses, radii of the circle, so x equals 3. Like, don't make that any more difficult than it is. But this guy right here, obviously this is not a radius right here, so we can't pull that trick. We know this has got to be x from a previous lesson, that since this is perpendicular, it bisects this segment right here. And you got to realize that this segment right here is the radius, so is this. This has got to be 7 as well. But this little part of it is 2, meaning this guy is 5. So this whole mamma jamma right here is going to be 12, right? So we'll say 12 times 2, which is 24, will equal x times x, which is x squared, and x equals the square root of 24, which is about, oh, I guess we need to simplify that, my bad. We can simplify that radical, so x equals the square root of 4 times 6, right, because 4 goes into there, so x equals 2 square roots of 6, which is about, you can punch that in your calculator, 2 square roots of 6, which is about 4.9. And down here you got some secants and some tangents. As you can see, this is a tangent segment because it only touches the circle in one spot, and this is a secant because it goes through the circle in more than one spot. And it's kind of just the moral of the story. You got two different situations. What if you had two secants intersecting, or what if you had a tangent and a secant? I'll give you the gist of all this right here. If you got a tangent and a secant, you take this tangent guy and you square it and set it equal to the whole length, right? That's the secret to this. The whole length, which is x plus 2.2, times the outside guy. This is the outside guy, right? So it's the whole dude times the outside dude, so that'd be 2.2 times x plus 2.2 as the quantity, right? You got to group that. So it's this dude squared times the outside dude times the whole dude. So let's do the distributive property and a little bit of cleanup. 3.3 squared, we can punch that in and get 10.89, and that'll equal 2.2x times 2.2 plus 2.2, my bad, I can't say it, is 4.84. So did a little distribution right there. And now let's subtract 4.84 over here and get 6.05 equals 2.2x, and then divide both sides by 2.2, and x came out real nice to be 2.75, but they say round to the nearest tenth, so x would be about 2.8. So that was the whole dude times the outside dude, and when that's a tangent segment, you square it. This is two secants times each other, so the rule is it's the whole dude times the outside dude. So the whole dude right here is 42. So I need to write 42 times 16, and I want you to write that out. Same thing here. I want you to write this out so I can see that you're taking the same two guys, the right two guys times each other, and that'll equal this whole dude, which is x plus 18, times the outside dude, which is 18, and that x plus 18 needs to be a group right here. So we will punch that in. 42 times 16 is 672, and then we will distribute right here and get 18x plus 324, if I could write it correctly. And then we could subtract 324 from both sides and divide by 18 and round it to the nearest tenth. 348 divided by 18 is about 19.2. 3. Here, again, it's 2 secants, so with the tick marks, if this is 8, that's 8 because of the tick marks. But remember, it's the whole dude, right? 16 times the little dude, so 8, the outside dude, I should say. 8 times 16 will equal the whole dude, which is 2x plus 6 times the outside dude. And like I said, I want you to write those 4 guys times each other so that I can see that you're taking the right 4 things times each other. We didn't have to do that up here because it's just so obvious. It's this times this equals that times that. But down in this one, just a little more complicated. And that would turn out to be 128 equals 12x plus 36. And subtract 36 from both sides and get a 90 deuce. And then divide by 12 and round to the nearest tenth. X is about 7.7. Here again, since that's a tangent, we got to square that dude. So 13 squared, and that'll equal the whole bad boy times the outside guy. So that's going to be 9 times 5x plus 9. 13 squared is 169, and that'll equal 45x plus 81. And then we will subtract 81 is the next move, and that turns out to be an 88. And then divide by 45 and round to the nearest tenth. X is about 2.0. Same kind of concept here. We need the whole dude, and I always put the variable first, right? So the outside dude times the whole dude, 6 times 4x plus 6. And then this whole dude is x plus 3 plus 6, which is really x plus 9. So that'll equal the outside dude of 6 times x plus 9. And what you see is you got the same number outside parentheses. You got 6 times all this and 6 times all that. Well, a real smart thing to do would be, well, let's divide both sides by 6, and those will go away. And those will go away, and you really have those 2 parentheses equal to each other. So now you could solve here and say, subtract x from both sides, that'd be 3x plus 6 equals 9. Subtract 6 from both sides and get 3x equals 3, and then x equals 1 right here. And finally, our last one right here. And let's figure out this whole dude, which is a 10. I need 8, the outside guy times the whole dude equals the x plus 11 is this whole dude. The outside guy, which is x, times x plus 11. And this is really, you know, even though this is nice and kind of in factored form right here, it's not equal to 0, so we got to always get this stuff equal to 0. So this is 80 equals x squared plus 11x. I went ahead and distributed that through. And it is a quadratic, but it's not equal to 0, so 0 equals x squared plus 11x minus 80. And now you can see that this is a trinomial. We want to try to find 2 numbers that multiply together to be negative 80 and add together to be 11. Or you could use the quadratic formula, but 80 is not that big of a number. You can write out multiples of 80. If they got to multiply together to be negative 80, though, one of them's got to be negative. So those won't add together to be 11. 2 and 40. But if one of them was negative, those won't add together to be 11 either. 3 does not go into 80. 4 does 20 times. But one of them's got to be negative, and those add together to be negative 16 or positive 16. 5 goes into 80 16 times, and if the 5 was negative, we'd be in business. So we can rewrite this as x minus 5 times x plus 16, because a negative 5 and a positive 16 add together to be 11 and multiply together to be negative 80. And now we can use the zero product property to solve this. X could equal 5 or negative 16. And then we can throw this guy out right here because you can't have a negative length right there. So x equals 5. So the quadratic formula would have worked. I think it's messy. I think factoring is much easier when the numbers are small. And yeah, I think 80 is a pretty small number. It didn't take me that long to find 2 numbers. Now, if it wasn't possible to factor this, then you have to use the quadratic formula. So That's 10.7. The homework is right here from section 10.7. We're just going to do problems 1 through 15. Nice, short, and sweet today. So let me know if you have any questions, and have a good one.